Here is the schedule for today. We're going to start with what are Phidgets. So again, just a general introduction to Phidgets, what they are, who uses them, all that. We're going to be transitioning to actually using that getting started kit that we talked about earlier. There's kind of two main paths now. There's a new browser environment that you're able to use, which is pretty awesome. That's brand new. And there's kind of the traditional route, which is the desktop environment, which is nice. We'll be taking a look at the sonar Phidget. So that is this one right here. This is a sonar Phidget, and it allows you to measure distance. So what we'll be doing is we'll just be taking a look at some of the code that actually drives that to get a little bit more of a technical look at Phidgets. We'll do some classroom examples. It gives some context about how people are actually using these in schools. And then I also have a few pictures in the slides that show some of that as well. So to begin with, what are Phidgets? So we can see at the top here, it says programmable USB sensors. So that is kind of the main piece about Phidgets. You generally plug them in via USB. There are wireless options available, so that is a point to remember there. But generally, you plug them in via USB. You write a few lines of code, and then you have this physical data in your software. So this is what a Phidget looks like. So again, this is that sonar Phidget. So all Phidgets kind of have this general look and feel. They have this black enclosure that we can kind of see here. They all generally kind of fit in the palm of your hand, and they generally do one specific task. So this one, for example, is a sonar Phidget, and it measures distance. So there's hundreds of these available, as we saw on those slides. So I'll go through a list of them later so you can see. But just on my desk here, I have a few just to show you. So again, this is a pH Phidget. So this will allow you to measure pH if you connect a probe to it. But again, same kind of look and feel there. We have some really good human input options. So things like thumbsticks, the thumbstick Phidget here. So again, this is great for any kind of, if you want to create like a game, students are using Unity with Phidgets. They're using Pygame 0. It's a really nice way to get user input there. We have some other options like moisture sensor. So this is a capacitive moisture sensor. We have a plant kit that comes that's available. So that's where that comes from. And then we even have some larger things. So, this is like a scale. So there's a little load cell in there. You can actually probably see that. And then there's a little amplifier here that actually takes a measurement from the load cell. And this would allow you to measure forces and weights. So lots of stuff available. Some from really basic stuff like lights. So, a very basic light sensor to more sophisticated things like the scale, motor controllers, lots of options. We generally say if there's a project that you're looking to do, with a coding project or an electronics project, you can generally do it with Phidgets. So how you actually use these is you would take a sensor. So I'm going to take this sonar Phidget again. So you take your sensor and you take your Phidget cable. So we call these Phidget cables. You're not going to be able to see this very well, but kind of looks something like that. They're just a simple 3-wire cable. And what you do is you would just take your cable, take your sensor, and you just plug it in. So just like that, you can kind of hear it snap into place there. So I'm plugging that in. And then what I do from there is I take my hub. So this is our kind of centerpiece. This is called the Vint Hub Phidget. This has 6 ports, and it allows you to connect all your sensors together and then to the computer. So what I'm going to do is I'll just take my sonar and I'll just hook it up to any of the ports on the hub. Same way that we did the other one. It's just like that. It kind of snaps into place. So now I have a sonar Phidget and I have a hub. From there, what you do is you grab a USB cable. So again, there are wireless options available, but this would just be the base case. So here is a basic USB cable, type A on one end and mini on the other. And what I'm doing is I'm just plugging in like this. So now I have sonar, hub, USB cable, and then all I'm doing from there is I'm just plugging into my computer. So plug that into my computer there, and I'll set this on my desk here so that everybody can see it. And then what I'll do is I'm going to share my screen again and just give you a really base case for using a Phidget. So as I mentioned, we do have options for browsers, but just say in the base case, you're using a desktop environment. This is a Python program that will talk to that sonar Phidget. So this is what it looks like. We'll go through the code later, but essentially you just press run on this, and then you get your physical data into your software. So this is now reading about 2 meters to my ceiling, or 6 feet. And then basically if I put my hand in front of that, we can see that update live. And now it's reading about 200 millimeters to my hand. So that's kind of the beauty of Phidgets, is that, you know, it took me 20 seconds to plug everything in, plug it into my computer, and then I can write code against that physical data using Python. I can use Python, I can use Java, I can use C#, I can use Swift. Basically any mainstream programming language you can use with your Phidgets. So here's they're kind of listed here. For education specifically, we support these ones. So Python, Java, C#, and Swift. Those seem to be the most common in high schools, especially Python and Java. That's primarily what we're seeing. There are options for browsers, so I'll show you that in a little bit. So if you are in a Chromebook school, that is also something that you can do. Just to give you a quick look at the sensors. So we don't, I won't talk too much about these, but essentially 158 different sensors here, ranging from, you know, pH to light to spatials, so accelerometers, gyroscope, magnetometers, distance, you know, encoders, basically, like I mentioned, kind of any project that you have in mind you can do. And then we have these controllers here, so motor controllers, you know, servo controllers, DC motors, BLDC, all that type of stuff. This page right here, this kind of website, and hopefully I'm actually sharing this. Yes, I seem to be sharing that. Okay. This page right here is the kind of consumer-facing site, like the engineers, the computer scientists, the researchers. That's who uses this site here. There's an education site, which we'll be focusing on today. That looks like this. So this is the site that you're going to be primarily staying on. So when you're interacting with Phidgets from an educational standpoint, this is the kind of website that you'll be using and interacting with. And then the last piece here I'll say is what we've done is we've done 40% off for educators. So all the prices you see on this kind of main website, these are for the kind of engineers and those guys. All these prices, we take 40% off for educators base, and then sometimes it's even bigger discounts. So we'll talk about that later, but all of that is in that buy tab here. So basically, as an educator, you get a pretty good discount on these professional tools. So going back here, I guess the last thing I've kind of been mentioning that Phidgets are used by professionals. I've kind of been mentioning that a few times. So what we have here is we just have some examples that we've been gathering. We gathered these for our educational users, basically for students and teachers, just to get an idea of who's actually using Phidgets in the world and what they're doing with them. So I'll put a link to this in the chat. And that will show you, that'll bring you to this page here. And essentially what this page is great for is just taking a look at how people are using these, what they're doing with them. So there's videos here. So for example, Artisan, this is the most popular open source coffee roasting software in the world. And this is the founder of that. And basically it's just a short video and they talk a little bit about Phidgets. So, you know, how are Phidgets used? And can you guys hear this if I play this? Let's see if you can hear this. Let me know.
No, we can't hear it.
Okay, let me just quickly change my sharing options so that you can actually hear that. So just an example here, and thanks Gita for letting me know. Just an example here, how Phidgets are used.
Certain aspects. So we use Phidgets to sense certain aspects of the roasting process, like temperature, air pressure, humidity, and also to control certain aspects, so certain actors. So of course, we use the temperature Phidgets. They are mostly the thermocouple ones and the RTD ones. Both have their advantages. And of course, we have ambient Phidgets that we use, things like air pressure, humidity in the room, and air temperature. And also the actors to control motors, motor controllers, and RC Phidgets to control these servo motors. And we have fidgets that control voltages, so voltage output fidgets we use.
So again, that's just an example. That's one of the most popular open source roasting software in the world. And there's a bunch. This is a company from Texas that uses Phidgets. Ruben Brewer, Dr. Ruben Brewer, he's a PhD from Stanford. He uses Phidgets in a bunch of his projects, and he taught with Phidgets. So just some really good examples there. And then what we also have down here are slides. So there's these slides here, and I'll put this in the chat there. And these are just more examples of who's using Phidgets and what they're actually doing with them. So kind of like there's two nice things about this. The one nice thing is, of course, showing students that they're using something that is, a real tool. And the other nice thing about this is that we find that students don't necessarily always understand how computer science can benefit them. Like they might say, an example a teacher told me was their student said, oh, I like chemistry, I don't like computer science, so I'm going to drop computer science. So by looking at some of these videos, they can see, oh, like, even though this one, for example, is a biologist who's studying trees. So even though Toby is studying trees and it's kind of more biology potentially, computer science is how he's actually collecting all his data, analyzing that data, and actually making it's what makes his research go. So I think it's nice to show students that computer science is not just for computer science class, especially as you get out of high school and junior high. Like there's applications in every field. So that's kind of the nice thing about that. So that's the introduction to Phidgets. So again, programmable USB sensors, they're essentially plug and play. And the idea is that the hardware is kind of done for you. So you don't have to do the wiring or the breadboarding or the soldering. You can actually plug it in and start using it. So really nice for computer science classes. Also really nice for I think Clay mentioned that he was in computer engineering. So what we have some teachers do is they might do something where they're learning about how a light sensor works, or how to build a light sensor. So they might do one section where they actually are breadboarding a light sensor using our Arduino or something. And then after they learn how it works, they transition to the Phidgets light sensor, because you can actually use that. So you can put it on a wall, you can put it on a car, whatever. It's not going to fall apart because we know that as we build things with breadboards, it's pretty hard to actually get anything that works long term with them. So it's kind of nice to show the two different things. Some teachers even introduce it with Phidgets. So it's, hey, let's use this light sensor, collect light data, and then they transition to, okay, here's how this actually works. We can breadboard something to have the same effect. So it's kind of nice in that way as well. Alrighty. So taking a look at the free kit offer here, it seems like everybody here has probably filled this out. If not, I'll put that in the chat there. And essentially, we're offering a free getting started kit. So this introductory kit here, you can get that for free by filling in the form at the end of that link there. And then what that actually comes with, just so that we're all on the same page. Let's see here. So when you get that getting started kit, again, it looks like this. So it comes with your hub. So that was that main kind of piece that we talked about earlier, and that's how you connect all your sensors together. That's what comes in the kit there. And you're also going to get a humidity Phidget. So this is a humidity sensor as well as a temperature sensor, so it can do both measurements. Apart from that, you're going to get some basic input and output. So you will get some buttons here and some LEDs, and then you'll get all of your kind of core cables to go there, and you get the little project box. So this is just how everything sits together, basically. So that's what comes in that kit there. And if you haven't received that, you can fill in that link, phidgets.com/education/free, and that will get you one of those. And then, hi Al, thanks for joining us. We're just kind of going through the slides here. I'll put the slides in the link here, Phidgets. Webinar. So the slides are in the chat, Al, and this is recorded, Al. So if you do want to take a look afterwards, we'll send out an email. We'll send out an email with the recording afterwards. Alrighty. So taking a look at the getting started kit. So let's assume that you have now received your getting started kit, and you're kind of like, okay, what do I do with this thing? That's what we're talking about now. And at this point, we're also kind of transitioning from the kind of professional side of Phidgets. So we're talking about how there's a professional side and educational side. Now we're kind of diving right into the educational side. So this is our kind of initial educational kit. So this was made specifically to introduce students to Phidgets. Now we've built tutorials, projects, lots of supporting material, and it essentially allows a student who's, you know, I've seen students in grade 6, grade 7 pick up their getting started kit, and they're actually able to use Phidgets, which is cool because this is a tool that people are using professionally every day. So pretty cool. So the first thing that we're going to do is we're going to go to phidgets.com/start. And that is, if you do have your kit, that is on the side of your box. You won't be able to see it in my video, but that's on the side of the box there. So this is what you would put in your kind of lesson plans for the first day that you're using Phidgets. So when you go to phidgets.com/start, you'll be greeted with this page here. And this is essentially allowing you to pick your path. So Scratch, of course, is kind of like the baseline that you would use Phidgets with. So if you're maybe grade 5, grade 6, that's probably where you would start. MakeCode is, and Scratch and MakeCode are both browser based. So this is if you have a Chromebook, or you're just starting out. These are both browser based. So MakeCode is a kind of step up from Scratch. So you do still have blocks, but you also have the option to use Python or JavaScript. And then desktop is definitely for high schools and kind of above. And that's where you're actually using our real APIs. You're using desktop environments, or you're using things like Eclipse, NetBeans, PyCharm, Python, Thonny, all that type of stuff. So right now, Scratch is almost released. So if you click on this, you'll get a page that says not yet released or coming soon. So this is going to be released probably in the next few weeks here. Browser-based coding with Phidgets is actually very, very new. So MakeCode, let's start with MakeCode. We'll jump in here. This will bring you to the MakeCode editor. And this basically allows you to interact with your Phidgets over the browser. So I'm just going to reset my page here so that we kind of are all seeing the same thing. And then what I'll do is I'll plug in my getting started kit so that we can kind of see how this works. So if you're planning to use Phidgets in the browser environment, so maybe grades like 7 to 9, 7 to 10, students who are maybe they've done some block-based coding, but they're not kind of all the way there yet. This is a great option for that. What you would do is there's a row here that says getting started. So what you would do is you'd have your students run through this row, and it'll kind of get them up and running with Phidgets. So for example, the first block here, this is showing them instructions on how to actually build their kit. So when they receive their kit, the buttons and LEDs will be the only thing that is installed, and then they have to add their hub and their humidity sensor. So this just shows step-by-step instructions on how to actually do that, and shows them what ports they should be plugging everything into. So that's the kind of first step there. The next step is they jump into the blink LED section. And again, depending on their level, they can obviously pick JavaScript or Python, but if they're just starting out, block-based is probably where you want to be. So you click on that, and it'll show them, hey, so the first step here is to learn how to blink the LEDs on your getting started kit there. So essentially what happens is there's step-by-step instructions up here. So, inside the forever block, turn your red LED on. They can use this light bulb up here to get hints about what their code should actually look like. And essentially they just kind of step through here, and then, they can see what they're trying to do. So here it's saying we want to turn our red LED on. We want to pause, and then we want to turn our LED off, and then pause again. So this is essentially going to get us the effect of the LED kind of blinking. So after they do that, it'll say, okay, finished, run your code and look at your red LED. So the only kind of note here is that there's a button down here that says device connected. I'll just reset mine so it shows that it's not connected. So I'll just do that quickly. So when you first get to this page, it'll show connect device. So you just want to make sure you click on that, and it'll say, okay, connect your USB cable to your hub, to your Phidgets. And then it's going to pop up a menu here where it wants us to connect. So it's saying, hey, MakeCode wants to be connected to your hub. So, okay, we'll click on that, press connect, and then we're all good to go. So that's just the one step you have to do in the browser to actually make sure that you're connected. After that, you should be able to press run. And then we can see here from my LED that we're getting that, that code running on our device here. So MakeCode's really, really nice if you're kind of in that junior high environment. I know a lot of schools are moving towards Chromebooks. So, I mean, you don't have to install anything. You just go to makecode.phidgets.com and you can kind of just start. So it's quite nice in that way. Obviously, it's not, if you're in the high school and you're trying to teach Python and Java, it's not a full-fledged, it's not the full experience of coding, but it's definitely a good step up from scratch. So essentially, after they do that, there's practice problems built into this. So, modify your code to flash the green LED. They're leveled, so they generally get harder as they go on. And there's also a page. We have solutions available for educators. So the idea is that your students should be kind of going through that top row. Then they work through these practice problems. And a lot of times teachers will assess based on these problems. So, show me that you checked off, show me that you completed all of the steps in the blink LED lesson. Okay, you did. Okay, now move on to use buttons, for example. So use buttons is the next one. It has the same flow here. It has the GIF here showing what you want to do. It has the instructions, and then the only difference here is that we want to try to get input from the button. So, we can use the blocks here to say, hey, if the red button's pushed, turn the red LED on, otherwise turn it off. So I press next. Okay, cool. I can press go, and then I have this effect where if I press my button, my LED turns on and off. So hopefully that's somewhat visible. And again, we have the practice problems. So that's the way that I would introduce students to Phidgets if you're planning to use the MakeCode environment. So you would run through this whole top row here. Again, all those practice problems have solutions, and there's a challenge at the end that has basically no instructions. It just has a challenge for them. And again, that's pretty good for assessment. Apart from that, there's some games that they can try out. So same type of flow here. It just has them building different games with their Phidgets. And then there's some projects. So we have some kits. I mentioned earlier, we have the scale kit, we have a plant kit. So again, those are projects that they can work through. And as I mentioned, so MakeCode is brand new to Phidgets. So what's going to be happening in the next few months here is that we're just going to be getting more rows and more content on MakeCode. But it's a pretty nice environment. We have sensor tutorials here, and we have all those links to the real world examples down there. And if you just wanted to use it, just collect data, for example, you can use this new project button up here. You'll get access to all the sensors, all the inputs, all the buttons, all that stuff. And for example, if I just wanted to read data from a sensor, which is actually quite a nice thing to do in MakeCode, I could just do something like this. I could log to the console. I have humidity attached. So we had that humidity sensor on the back of our getting started kit there. That's on port 3. So we can say, hey, I want to log the temperature from port 3. We can run this code here. And then there's this show console button that shows up when you use the console block. And this will actually give you a live graph of your sensor data. So again, even though MakeCode is simple and it's good for the junior high students, if you just wanted to collect data, so say you're in a science class and you have a thermocouple or you have a pH sensor and you want to just monitor something, it's actually quite nice for that. As you can see here, we have this data streaming in, and then what I can actually do is I could pause the graph and I can actually just download this data. So it's going to give me a CSV. So literally with no extra code for myself, I now have a CSV of this temperature data, and I can insert a chart here showing all this data. I can run analysis on this. It's actually a really, really nice tool, MakeCode. So pretty interesting stuff. So that is the MakeCode world. So if you are in the high school or older, so it sounds like Clay and Jita are probably in this world here. What you would do is you'd have them go to the desktop, and what this is going to do, it's going to bring them to our Getting Started Kit tutorial for the desktop here. So this is basically the same thing as we saw in MakeCode. The only difference is that it's actually giving you the desktop version. So you're going to have a development environment. So something like Eclipse or PyCharm. That's kind of the main difference there. And the other difference is you're actually coding against our real API. So the same, the same API that professionals are using, that's what you're coding against on the desktop. So the first thing that you do when you get to this page here is you would set your language and your environment by clicking on this button right here. And that will bring these options up right now. So as you can see here, we have Windows, Mac OS, Raspberry Pi, all the languages that we support, and then development environments are on the last row. So for example, if I'm using Windows and Java, I can use NetBeans, processing, or Eclipse. If I want to use Python, I could use Thonny, PyCharm, PyScripter, et cetera, et cetera. So today I'm on a Windows machine, I'm using Python, and I'm going to be using Thonny. From there, what happens is I've now set up with Python and Thonny. And essentially what I'll do is same kind of flow as last time. Students would start at building their kit. The only difference now is they'll have this configure step. So the configure step is how they actually configure their development environment. So that's kind of the difference, right? Like when you're coding in the browser, everything's just set up and ready to go. But when you're actually coding on, if you open up Thonny, Thonny's just, another development environment. But if you open up Thonny, it doesn't know how to talk to Phidgets until you add the libraries. So that's kind of the only difference there. So the build kit is the exact same thing. Images here, everything like you would expect. The configure is where you get the instructions on how to actually configure your environment. So, we can see here to start, open Thonny, and we want to add the Phidgets package. So if you're familiar with Thonny, if you're familiar with Python, you'll probably be familiar with pip, which is the third-party package installer. But essentially all you have to do is just search for Phidget 22 native, like that. And then you just install and you're good to go. Essentially, if you're working on a Windows machine, that's all you have to do. You don't have to download anything externally. There's no software to install. You can just do that and you're ready to go. And again, all the instructions are kind of listed here. So it's pretty easy to get started. All these instructions they were basically built in the classroom. So we worked with schools for probably over 2 years developing this content. So everything's been tested in the classroom. We understand how downloading software can be very painful in high schools. So we try to make everything work without an install, and everything has been tested, so it's very smooth. After you configure your environment, you're going to work through the kit in the same way that we saw in MakeCode. So you're going to start by blinking your LED. It's going to be the same type of format we saw. So you're writing code in Python. The only difference is you're actually getting the code now, of course. So you can copy the code. You can paste it into your Python programs. So I'll just paste this in, for example. You can run your code, and then you get that same result that we got in MakeCode. The only difference is now we're interacting with the Python API. Same type of thing as well. You have the practice problems. You have solutions that are available. And essentially students will just go kind of, same type of thing. You'll assign, generally what we see is teachers assign, lesson 1. So it's everyone complete lesson 1 today, and then show me the practice problems when you're done. If you complete that, then move on to lesson 2, et cetera, et cetera. There's practice problems at the end here, practice projects, sorry. There's a final challenge here. And then what there also is advanced lessons. So this is slightly different than MakeCode. So because it's a professional tool, there's a lot of layers that you can peel back if you choose to. So there's things like events, there's things like, I think I just opened up LED brightness. So things like brightness, you can change the brightness of your LED by changing something called duty cycle. So this is something that, Clay, for example, may be doing in his engineering classrooms, is talking about duty cycle. So we kind of go in more depth with that, error handling, APIs. Each sensor, of course, has its own API. So this is a nice way to kind of give students a practical example of what an API is. This is, for example, that API for the humidity fidget. So you can see, okay, that it has a data interval. It has, these are all the functions and methods that are available to it. So the advanced section is quite nice, especially probably for the grade 11, grade 12 students. It's a nice way to get introduced to a lot more content and more advanced concepts. So that's the Getting Started Kit on the desktop environment. And essentially what you would do is, I'm just to kind of give you guys a quick overview of what you would do after the Getting Started Kit lesson. So you've done the Getting Started Kit tutorial. What is next? If you're on that desktop environment, we have this Learn tab up here. So there's device tutorials and there's projects. So there's kind of 3 levels. So level 1 is that Getting Started Kit. Level 2 is device tutorials, and level 3 is projects. So basically that's kind of the steps that you want to take. You want to start with this, and then you kind of move on, because the Getting Started Kit gives you the base that you need for everything else. So device tutorials just give you information about all the sensors that we specifically sell to education. So I mentioned that we had hundreds of sensors, and what we've done is we've taken a handful of those and basically wrap them in content and tutorials and projects for education. So these are the ones that kind of work the best in the education world. So for example, the power plug fidget, this is something that allows you to easily control power to a 120 volt device. So, you know, it shows you some base information here, shows you how to actually get connected, and it gives you the base code here. And then again, there's some applications and some practice problems. So that's what the device tutorials look like. And then from there, there's also the projects. So in that projects tab, we have a bunch of different projects here, just showing more things that you can do with the Getting Started Kit. So more projects, more tutorials, all of that. And then we have some of our kits. So, you know, the rover kit here, the planet kit, the scale kit, Pygame, like I mentioned. So some of these, when you click on them, so for example, I click on Pygame, this will bring you to a page that has even more content. So there's actually quite a lot of content and quite a lot of projects that are available. So definitely something to note if you're on the desktop side of things. If you're on the make code side of things, it's a very similar thing. The only difference is that everything is on this one page. So if you're on make code, all your sensor tutorials are right here. They have the same content as the other one. They're just all listed here. And essentially what you'll see is more projects and more games being added here. So that is the kind of flow. You introduce them with the Getting Started Kit. You transition to devices and to tutorials and projects. And a lot of times students are making their own projects, or they have a problem they want to solve. So that's what you would end up doing there. What I want to quickly, I'm just going to quickly do this as a bit of a code review. So just so that we have an understanding of what the code actually looks like. It seems like most people here are kind of in the high school level. So I'll just focus on that right now. So, you know, taking a look at a Python project, for example, you're always going to have import statements up here. So that's because you're pulling in that third-party library, and this is how you reference them. But it's pretty straightforward. It's the same in Java. You just have your object creation. So you're always going to create an object. You know, I have a distance sensor connected, so I want to create a distance sensor object. I'm opening my Phidget. That's how you bridge your software object with your physical Phidget. After you call open, those two get bridged. And from there, you just use them. So you're just saying, you know, distance sensor dot get distance. It's extremely simple, but you can do a lot of sophisticated things with it. It's really easy to add multiple Phidgets to the same project. So, you know, if I wanted to add a light sensor here, I would just import the light sensor class like this. I would create a light sensor object. Oops. And then I would just open it. So, you know, it's really, really easy to create multiple projects, and then I could just use it. So it's really simple. You know, you could create a control system here. Say you wanted to, we saw that power plug Phidget. So if you wanted to turn on a lamp because it got too dark in the room, that's very, very easy to do. There's lots and lots of options there. So classroom examples. So this is a high school out of Eastern Canada that basically they're pretty advanced students. So what they did was they went through that Raspberry Pi tutorial, and they actually ended up connecting a bunch of sensors to their Raspberry Pi, and they ended up monitoring a greenhouse with that. So the problem they had was that in the summer months, a teacher would have to drive to the school to check on the greenhouse temperature. And if it was too hot, they'd have to open a window. Too cold, they'd have to close the window. But they'd have to go down to the school to actually figure out what the temperature was. So what they did was they created a website using Phidgets and the Raspberry Pi, and they basically just hosted that information for anyone to see. I have an example of that here. So this is actually a plant that's at my house, and I have that soil moisture sensor. So that one that we saw here that looks like this, I just kind of have this in one of my plants, and right now it's measuring the soil moisture level. And this is just live, so you can see the values changing there. And that's kind of what they did there, but they did it with a bunch of different sensors. It'd be really easy to add a button here and to add a motor controller on the other end. Say you want to water the plant, you could do that with a button there. Pretty cool stuff there. Schools, a lot of schools are doing Unity, Pygame 0, kind of the 2D and 3D game development. Phidgets works really well with that because, for example, Unity, if it's based on, it's based with, you code against it with C#. So we have a .NET library, and you can just plug in your Phidgets and start coding. It's really easy. Lots of robotics examples. We have our own robotics kit, and then people take our stepper motors, our servo motors, and they do a bunch of stuff with them. So that's always something that's common. Aquaponics, science, there's obviously a lot of connections here. The nice thing with Phidgets is the price is quite inexpensive. So there's a lot of really nice things you can do that don't actually end up costing that much. So that's awesome. And then I guess just to touch on that here, we have that buy tab up here. And this is where you would actually see the prices for education. So we saw that the other prices before, but these are all the educational prices. So just to give you an example, the Rover kit, it ends up being $55 for a kit like this. So if you are interested in robotics, that would be a good option there. It has a wireless hub, a motor controller, and a sonar fidget. And what we do is we try to make sure that every kit that we sell is modular and can just be taken apart. So, we have schools who take the Wi-Fi hub apart, and they use it in a different project for something totally different. Same with the sonar and the DC motor. The idea is that you're not buying a single-use kit; you're just buying more parts essentially. But that's fairly inexpensive. The plant kit is $25. Scale kit's $30. And then all the sensors are generally pretty inexpensive. So you can actually get quite a lot of interesting hardware, and it won't end up costing you that much. And it is professional grade, so it does end up lasting longer and being fairly reliable. So that's a good point there. So I did run out of time a little bit, but we do appreciate everybody stopping by. Here is our kind of contact links here. So education@phidgets.com. That's our general email. So I'll put that in the chat here. If you are on Twitter, we're pretty active on Twitter. We share, new projects and webinars and all that stuff. So definitely something to check out. But we appreciate everybody stopping by. Thank you for doing that, and have a great night.